Hello everybody, welcome to Marketing Analytics course. This is Dr. Sagadar Chatterjee from Vijayasom IIT Kharagpur who is taking this course. We are in week 7, session 3 and we will discuss about recommendation engine. In this particular video, I will do a hands-on on item to item collaborative filtering. So, to do that, there is this easy.r file that I have opened. Easy.r because there is another file which has been taken from internet and that coding was very difficult to understand for a newcomer. So, I have changed that particular coding to a easier form and the data is about move. So, the data looks like this. So, if I just open the data, so this is a user. These are, if you see it carefully, these are users and these are various, I would say, FM radio channels or radio songs. And 0 and 1 means whether one user has listened to one particular thing or not. So, this is something that you have to create. The user in the left side, the items in the column, and 0 and 1 is saying that whether something is seen or not seen by a group of users. So, based on that we are creating this, and then the first thing is to read the data. So, we will set working data into source file location and I will read the data. So, the data, this one is a smaller version of that data. So, I have taken only 19 users and only 13 variables, but this is based on this sample.csv file which is a small file, 1 KB file, but you can also do it with the bigger file. So, you can change it to let us say last FM matrix Germany and you will get the bigger file and you can do the all your calculation based on that. But because I have a time issue, it takes probably 3-4 minutes, 5 minutes in the calculations if I do it in the bigger file. So, if I do it in bigger file, it will have, so just to give an example, so last FM Germany, rename, copy. So, if I just read that, you see there are 1257 observations of 286 variables, means 286 people are there and 1257 observations are there. The calculation will take some 1 minute, 2 minutes and I cannot sit idle in a video for 1 minute, 2 minutes. So, that is why I am using a small this thing. You can use the bigger one as well if you like. So, given that I have read this data 19 observations of 13 variables and we will start with this. So, the first thing that we will do in the various steps of this calculation, we will create holder. So, let us draw it. So, what is the holder? The first thing is, see here we have m number of customers and n number of products. This is what we have. So, product 1, 2, 3 up to capital N and customer 1, 2, 3 up to small m. These are my users and these are my products. So, from item to item, what do we do? I find out this item and let us say this item. What is the similarity between these two items? Let us say 3 and 10. The similarity is calculated by this way. Let us say the item 3 is Professor X and item 10 is Professor Y. And these are the students, and the students has rated Professor X as, or in this case purchased. So, let us say various students has taken the courses of Professor X and Professor Y. So, this guy has taken 1 1 0 0 1 1 0. Let us say this is the case, and in Professor 10 guys are taken 0 1 0 1 0 1 1 0. And in Professor's 11, there is another guy which has been taken 0, 1, 0, 0, 1, 0, 0, 1. This is the thing that he has taken. Can you tell me by saying that which professor is closer to which professor, which two professors are more closer. You will see that these two professors, whoever taken professor 3's class, how many times they have also taken professor 10's class. So, professor 3's class and professor 10's class, this is a tick, this is a tick, this is a cross, this is a cross, this is matching, 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 matching. So, professor 3 and professor 10 out of 1, 2, 3, 4, 5, 6, 7, 8, 8 guys, 6 by 8 times the preferences matches. Whoever has seen 3 has also taken classes of 10, whoever has not taken classes of 3, I have also not taken the classes of 10, that kind of matching has happened 6 times. But here this is match, this is match, this is not a match, this is match, this is not a 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 match. So, 3 by 8 times, and that gives me an idea that 3 and 11 are closer than 3 and 10. So, that is how we will be going to create a similarity matrix. Now, I will use the cosine matrix to do my calculations. The cosine is cosine of 3 comma 10 is basically the formula is summation of x y. So, covariance. So, this is the formula that has been written. I will come to that just 1 minute. Summation of h into k by summation of k. So, that is what we are trying to use. So, cosine just 1 minute, cosine is So, that is what I am trying to create as my cosine matrix, and then we will try to find out. Now, if I have to find out the similarity of cosine into 3 into 10, what is the cosine will be for 10 into 3? Same thing, whatever I get here, because the formula is basically this matrix into this matrix by, so x into y, summation of that divided by summation of x by summation of y, something like this. So, if that is my cosine, then I will get the similar thing here as well. So, if I get the similar thing here as well, then if I try to plot them in a if I try to convert it in a matrix, how will it look like? Each item to each item. So, this will create n number of products here and n number of products here, and this will be a similarity matrix. So, n into n similarity matrix gets created. Fair enough. Now, what is the similarity of the diagonal elements? It will be exactly 1, because I am absolutely fully similar to me. And then it will be either upper triangular or lower triangular symmetric. So, whatever is value here comes here, whatever value here comes here, and so on. So, upper side and lower side is symmetric. So, one set of calculation you do, other set of calculation you do not do, it is okay. So, that is how we are reducing the number of calculations. So, this is what I will first try and find out how items are closer to another item. So, to create this matrix, to populate this matrix, I have to create the matrix holder. We are naming it as A. A is a matrix where all the entries are 0, number of row is 12, number of column is 12. Why? Because there are 13 variables. Now, out of this 13 variable, the first variable is user name. So, that is why we will not using. The rest there are 12 items, that is why 12 by 12 matrix I am creating. Right now, this A matrix is a blank matrix, it is a blank matrix, nothing is written here. Fair enough. Now, I change to create, I change it to a data frame, and then what will be the name of the data frame? Remember, this is the matrix that looks like this. The row names will be the row names, first of all the column names of this matrix will be similar to these values, the column names of this matrix, and the row names will also be the same. So, the row names and column names both will be similar to the column names of the first original raw data set. So, call names of A is equal to call names of data.Germany. Why -1? Because first entry is user, that I will not take. So, if I just take this part, copy it and run it here, it gives me 13 entries with the first name as user. So, this one I will not take, this one I will not take. So, that is why I am writing this, and I am not getting the user one, the rest 12 is I am getting. I am putting them as column names of A. And I am also saying that row names of A and column names of A is same. That means, the row names and column names are same. Now, how does A looks like at this moment? A looks like this. All the entries are 0. We will do the calculations, but these are the product names. These are some product names. Fair enough. Now, what I will do is, I will calculate the cosine, or here I have calculated the correlation. So, correlation is also fine, I think. So, how to calculate the correlation? So, easy formula is correlation. What is the so the higher the correlation, the higher is my, I would say, the higher is the similarity. So, for I is equal to 1 to 12, for j is equal to 1 to 12. So, this is something for I is equal to 1 to 12, for j is equal to 1 to 12. A of I j, that means ith row jth column, is correlation of what? Correlation of data dot Germany's I plus 1th column and data plus Germany's j plus 1th column. Why plus 1? Because the first column is the user column. The first column is user column. So, let us say, to give an idea, I want to populate in this A, I want to populate this value, let us say this value, which is AC dot DC and ABBA. In the column, it is third column, in the row, it is the second row. So, what is the case? The third column, second row. So, I is equal to 2, j is equal to 3, fair enough. Then, what is basically correlation I plus 1? So, what is this value? This value is 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, something like that, which is basically the third column. If you check carefully, this is the third column, 1, 2, 3. This column 0, 0, 0, 1, 0, 0, 0, 1, and then 0, 0, 0, 1 and 0. This is what I am populating here. So, this is the third column, and with that j is equal to 3, that means, the fourth column I will take a combination. The fourth column looks like this. Fourth column looks like this. What is the fourth column? In the data Germany, the fourth column is ACDC. So, these two columns correlation I am trying to find out. That is why I plus 1, j plus 1. And then after finding out, I will put them into my A matrices or A data sets, I comma jth cell, I will populate the value. So, that is what I am trying to do. And actually, I should not have calculated 1 to 12. It would have been better if I have calculated from I is equal to 1 to I rather than 1 to 12. J is equal to 1 to I, because see, it is a matrix which is lower triangular matrix or upper triangular matrix. The other things are same, it is symmetric. So, I could have calculated lower triangular matrix and find out the symmetry, but I have not done that because it is a smaller size, it will not take time. So, that is why I have done this. So, I A I j is equal to correlation of this and this. So, if I run these 3 lines together, I get all the correlation values. See, it is 0.13043, 13043. It is symmetric to over the diagonal. All the diagonal elements are 1. And the other correlation values are written here. Fair enough. Now, this is something that I save, because this is something that I will use later. If it is a huge data set, it is better to save it. Now, what will I do next? You remember that these correlations are between correlation values. Correlation values are between -1 to +1. I am trying to make sure that all of them are scaled properly. So, they remain from 0 to 1. So, what I am writing? I am writing, it is called normalization. We have done this before. The normalization is done in this way. So, I am saying that the new item new value is x minus minimum of x, where old value is x minus minimum of x by maximum of x by minimum of x. Let us say the minimum of x is minus 0.73 and maximum of x is all I know that 1, because 1 we are getting. So, then this value will be x minus 0.73 divided by 1 minus 73, or in other words x plus 0.73 by 1.73. Fair enough, this is the value that I get. Now, let us say one particular value is 1. When it is 1, the new value will be 1 plus 0.73 by 1 plus 0.73, it will be 1. If the value is minus 0.73, then the numerator becomes 0, this value becomes 0 and the denominator stays. So, then I know that okay, numerator becomes 0, denominator stays. So, that means that the minimum value is 0. If x's value is 0, something in between, then the value will be, when x is equal to 0, this new value will be 0.73 by 1.73 or something like that, whatever value comes here. So, it is now covered between 0 and 1. So, that is what I am trying to do here. I am putting them into 0 and 1. Fair enough, I am putting them between 0 and 1. Now, what next? Now, I am trying to create a matrix which is a similarity matrix, which is a recommendation matrix, which called R. So, I wrote R is equal to data Germany, then R is equal to R minus R. By running these two lines, simply what I created is 19, these are my users, these are my items. Okay, sorry, this is something that I probably have done wrong. R is equal to data Germany, and then I would write R, 13 variables. So, 2 to 13 is equal to 0. That is the right thing to do. I am sorry. So, if I run this, then what do I get? The users, the items, and currently all these items are 0. So, I will find out the recommendation scores for these items. How do I do it? Now, what did I do till now? I created only a similarity matrix. If you remember, I have created a similarity matrix which is saying that the higher the value, the more is the similarity, the lower the value, the less is the similarity. So, I started with m users in items. From here, I have created n by n similarity matrix. This is what I have created. Now, I have created recommendation matrix which is currently blank, which has m users and n items. So, now choose any one cell. Let us say for this cell, the user number is 3, the item number is 5. Now, for the third user, I will, my recommendation decision, the recommendation decision R 3 5, the recommendation decision will always be 0 irrespective of anything if this is the purchase history. The purchase 3 5 is 1. That means, if I have already purchased it, I will never recommend. So, the first thing that I will check is that whether this value is 1 in this case or not. If it is 1 here, it will always be 0 here. So, that is what I have written here. Carefully you see that for I is equal to 1 to 19 and for j is equal to 1 to 12, 1 to 19 means the number of observations, number of customers, and j is equal to 1 to 12. This happens only if data dot Germany, the original purchase data, in that the value is 0. If it is not equal to 1, then only happens. otherwise it does not happen. Otherwise this calculation will not happen, the value will remain 0. The value in the recommendation will remain 0. If by chance this is 1, this is not equal to I have written, by chance this value is equal to 1, that means in the purchase data third customer has seen fifth product, then I will not recommend that product anymore. If third customer has not seen the fifth product, then I may recommend based on the calculations that we are going to do. But if he has already seen, I will never recommend. So, that is why this thing. Now, if he has not seen, then what is the question? Then what? If by chance let us say this guy has not seen it. So, then if he has not seen, then what do? I simply find out that okay, item number M, if this is the item, which are the top similar items. So, let us say I find out item number M has similar items from this matrix. I will get actually this information that item number 6, 9, 11, 13 and 17. These 5 items are most similar items to item number 5. Now, I will recommend item number 5 to user 3. Listen to this carefully. I will recommend Mahuna to my friend. Here we are doing item to item collaborative filtering. So, all the similarity is measured based on items. So, I will recommend Mahuna to one of my friend only if I have seen that my friend has also seen similar movies like Mahuna. Listen to this carefully once more. I will recommend one movie Mahuna to my friend or anybody if I know that that somebody has also seen movies which are similar to Mahuna. Fair enough? So, which are similar to Mahuna? If Mahuna is item 5, then item 6, 9, 11, 13 and 17 are similar to Mahuna. Now, for these 6, 9, 11, 13 and 17, whether they have seen it from which matrix I will get? From this matrix, that whether user number 3 has seen it. So, user number 3 has seen the 6th item will come from here, this cell where this is 6, this is 3, has 6 the 9th item, this is 9, this is 3, has seen the 11th item, this is 11, this is 3. That is how I will find out whether this guy has seen these items. And I see that okay, this guy has seen this, not seen this and this. Fair enough? Then his net similarity score is basically 1, basically similarity of 6 plus similarity of 11 plus similarity of 13. Let us say 6 similarity is 0.73, means similarity of item number 6 with item number 5 is 0.73, item number 11 with item number 5 is 0.42 and item number 13 to item number 5 is 0.33. So, this is his net similarity score for product 3. On the other hand, let us say in another situation I see that this guy has not seen this, the rest 4 he has seen. Okay. And if the rest 4 he has seen, corresponding values are coming, let us say 0.62, 0.42, 0.32 and 0.29. In the second case, this is in the second case. So, you will see in the first case the total value is 0.73 plus 0.42, that means 1.15 plus 0.33, 1.48. And in the second case it is coming more than 1.48. So, in the second case the recommendation chances of recommending item 5 will be much higher, though he has not seen the most closest movie. So, this is something that is what we are doing. So, what I am doing? Carefully you see. What I do? I do k is equal to sort A comma j. What is A comma j? J is the product. So, I will just quickly check this. Let us say I is equal to 3 and j is equal to 5. Data Germany I j plus 1, what is the value? 0. So, I can go ahead. He has not seen before. Now, what is this A comma j? That means A, that similarity matrix, jth column. These are the similarity of jth product, that means fifth product with other products. You see, the fifth product similarity with fifth product is 1, his similarity with himself is 1, and these are the rest of the thing. Now, if I try to find out which product is the most similar, I have to sort this out. Fair enough. So, that is what I am doing, sorting. I am sorting it out, and it comes to be the first item to be 1 because I am most similar to myself, but it has no meaning. The next 5 items similarity is like this. Fair enough. So, that is why I take from 2 to 6. So, k is equal to sort A j 2 to 6. So, k is basically the top 5 items, item number 5, whichever other items are closest to item number 5, corresponding similarity scores are this. And if I want to find out order means the serial number of minus aj will give me the order. Fifth item is most similar to fifth item, then fourth item, then ninth item, then first item, then third item, and so on. So, these are the order, this is not the similarity score, this is the order of the similarity score. So, that 2 to 6, if I put it in L, this gives the identity. So, fourth, ninth, first, third and sixth items are the topmost similar items to item number 5, and corresponding similarity scores are this. So, K stores the similarity scores, L stores the similar items. Now, I have to check out of these whatever items has been stored in L, whichever has been seen by the ith customer, in this case the second customer or third customer, I is equal to 3, the third customer, whether he has seen it or not. So, how will I know? This Data Germany I comma L plus 1 because the first column in the Data.Germany data set is the users. So, this is my history. The history says H is 0, 0, 0, 0, 0. So, he has not seen any of these movies. Then how much will be the probability? 0, because 0 is my history into the similarity score by the sum of the similarity score. So, that is something that we calculate and put it in R I j plus 1. So, the value becomes 0. This particular value will still become 0 because all my H items are 0. If by chance one of them were 1, any one of them were 1, corresponding value would have been calculated. Now, this is the operation that I do for all my products and all my users. If you did not understand this, please stop the video, go back and understand it properly. So, I run that. Now, I have created the R matrix. Some of the values are coming 0. 0 can come for 2 reasons. One is this guy has already seen the movie before, that is why it is coming 0, or this guy has seen no similar movie. We have taken the top 5, no similar top 5 movies, that is why the value is coming 0. These are the 2 reasons why these values can come 0. Whenever he has seen at least one similar movie, then some value will come here. Now, what I do is next I will create the recommendations. So, these are the recommendation scores. I need actual names of the movies. So, what I create is I create a recommendation matrix which has 19 rows and 5 columns. Right, 5 columns because top 5 recommendation will come. In normal case in Netflix and etc., 5 recommendations come. So, top 5. The row names will be the user names. So, that is how the user names are coming here. These are the user names, and V1, V2, V3, V4, V5 will be the name of the. So, the names are Reco 1, Reco 2, Reco 3, Reco 4, Reco 5, the 5 recommendations for these users. And what will be the recommendations for I is equal to 1 to 19? Carefully see. For I is equal to 1 to 19, what do? First I find out the corresponding entry of R. Carefully you see. Let us say I am trying to find out the first guy's recommendation. So, this is what I have created before, the recommendation matrix. So, if I just find out what is the first row, this is the user, forget about it, and then these are all the values. Now, this is all 0. So, this will not help me, these are all values as 0, but let us say the second guy, let us say I is equal to 2. So, then what is RI? The username is 33 and he has 0.16 value here, 0.38 value here and 0.59 value here. So, his chances of seeing Alex is on fire is the highest, then comes AC.DC and then comes a perfect circle. So, these should be the recommendations for me, fair enough. So, how will I do that? I will order this. Basically. So, what I am doing here is order IHL and 2 to 12 because first entry is user. So, that I am ordering in a reverse, that means in a decreasing order. So, this is my, when I is equal to 2, this is how it looks like. 9, this Alex on fire was 9th entry, then third entry, then first entry and so on. Then this plus 1, why I am doing plus 1? Because I am trying to find out the names of these movies from the original data set. The original data set's first column was user, that is why plus 1. So, 10th cell, 11th, 10th column, 4th column, 2nd column, 3rd column and 5th column will give me those columns names will give me the corresponding movie names. So, then what do? I am saying that if the call names of this, that means these are the call names, Alex on fire, AC/DC, a perfect circle and then Abba and Adam Girl, these has been taken, these are all zeros, this has been taken randomly. So, these 3 matters basically, and then I am taking the top 5 only 1 to 5 because I am giving 5 suggestions only. So, the last 2 suggestions are random, the first 3 suggestions in this case because there was some positive value I am getting some suggestions. So, these are my suggestions. So, now if I run it for all of these guys, that populates suggestions for each of these people. So, for 33 this will be the suggestions, for 42 this will be the suggestions, for 62 this will be the suggestions and so on. So, that is how I create a item to item collaborative filtering. So, once more what did I do, what are the steps? First I had this, I will just do once more. First I had M items, M users and N items, purchase data 0 1 purchase data. From there I calculated a n by n similarity matrix. Then I calculated this is purchase data, this is recommendation matrix of M users, N items. Here the values are the recommendation scores, how the strength of the recommendation, and based on that for each M users we suggested top R1 to R5 top 5 recommendations based on the scores. Whichever score is higher will be the first recommendation, whichever scores is lower will be the second recommendation and so on. So, these are the steps that I have created in item to item collaborative filtering. So, we have done it for a smaller data set. There is a bigger data set called LSTM FM matrix Germany. It is available in publicly available data set. You can use it and you can try out and find out that whether you can create a recommendation engine with the all 1257 these things. and 286 users and 1257 items. You can create it will take some time, same thing, it will take some time, but you will get a result for that. So, thank you very much. I will come back with user to user or user based collaborative filtering. Thank you.